going to do is suppose that this node ASU 1.2 has some kind of minor hardware error. Maybe it has a predicted failure on one of its drives, and I'm going to say that because that's an example that we used before. Now we can see that is not the case. All its drives are good, but let's just say that it was. And we think that we want to remove this node from the system so we can replace it, but you can't just replace it. It has data on it. I mean, if we just replaced it, Reconstruction would run, but that is not what we want to do because it's kind of irreversible. We want to do things much more gracefully. So we want to remove this from the blade set. We have two ways of doing that, one of which is drain, which is for somewhat healthy nodes, and drain, the volume owner is going to move the components off of this node and put them onto other nodes. As a matter of fact, we're going to status and reports and look at the storage statistics right now. We looked at this a little bit yesterday, and we saw, you can see that the realm is idle, but we can see that other than this flaky one that's a little bit larger because it came from a different realm, that capacity used is about the same, the available is about the same, the reserved is about the same. So we're going to copy the volume owner directory is, copy the components, move the components off of this node onto the other nodes, and it's going to write them into reserve space on the other nodes. And that's because, so we can get rid of this node right here. So the process that we do to do that, we're going to go to that node. ASU 1.2. Let's scroll down here. You see this button, Start OSD Drain? We're going to click that. And even though this is perfectly reversible, it does require confirmation with a capital YES. I'm going to go OK. Yep. It says it started draining on OSD ASU 1.2. This button is supposed to change to Stop Drain. You see that it did, but it's grayed out, which is a very minor bug. And part of the reason it's not been fixed is that's really not the best place to stop drain in the first place. So under hardware, we have over here on the left, drain status. This tells you everything you want to know about anything that's draining. And Mike, no, I'm sorry. You won't be doing this. I confused this with another situation. So already it's at 0.08%, which is actually pretty good. There is no ETA because it doesn't have enough tracking information, and it is in progress. Okay. And there is here a button that does work, stop the OSD drain, and there's another button to stop all drains right there. So let's go to status and reports, storage statistics, and look what's happening. We've got a whole lot of reads from the node that it is draining, and we've got writes to a number of other nodes. That's not writes of files, that is writes of a specific components. The performance manager is getting a listing. A performance manager is one of the services on the directors. We're not going to go over that in this course. Is telling this OSD to give it a list of all the components it has, and it's working in a particular volume at a time. And it's the performance manager is giving that list to the storage manager on the volume owner director. The storage manager is making batches and says, I want you to copy, I'm going to create a new component on some other OSDs. And it's just copying different components to different OSDs. I want you to copy it over, and I want you to delete the original one. Then I want you to fix the map so that the object now knows that it is on one of the components on a different OSD. So if we refresh that, we've got more OSDs being written to. Again, a whole lot of writes to this one right there. You see already that the available space is increasing on this one, and the reserve space is increasing, because the reserve space eventually will get to 100% on this one. That means it can be removed from the realm. I'll show you that later. And the reserve space is gradually decreasing on these. It's hard to know that because these components are being written to reserve space. They're just being written to the disk wherever ButterFS decides to put it. But in the space accounting on all these OSDs, they are decrementing the free blocks they have in reserve space. Okay. While they're doing this, we will talk about volume services. Storage. We talked about volumes before. Now we're going to talk about service ownership. The directors manage metadata through these volume services. They do manage the volumes individually, but they mostly manage this through a volume service. You could have 500 volumes on your realm. We don't want to administer all those together. So the various volumes are put into a volume service. By default, each director gets one full volume service, and there's a little one just for root. Just like the volume, a root gets one all its own because it's so important. So let's say we wanted to replace ASD 1.1. This is similar to the rep set. We don't want to just yank it out because this volume, the president would have to fail this volume service over to make the metadata on these volumes available. And there would be a 90-second delay before it did that. And we don't want all the volumes to be down for 90 seconds because they would be. So we're going to move this volume service to one of the other directors. Now that, in fact, takes the volumes down, but it's more like 1 second, which is better. So down here in this form right here, there's a form to move the volume services. What we want to do is move all the volume services that are on ASD 1.1, the primaries. We're not going to worry about the backups. As a matter of fact, we can do another search, ASD 1.1, and we can see that it is the primary director for 2 and the backup director on 1. What is a primary and a backup? The primary director is responsible for all metadata services on for the volumes in that service ID. The backup is doing absolutely nothing but receiving transaction records from the primary. Some of these transactions are very, very important. We don't want to lose them because we don't know what state the metadata is. We don't keep track of the individual client callbacks, but we do keep track of which clients have callbacks, so we can notify them. Those are critical metadata transaction logs. We keep track of what we have told the clients recently. So if the client said, hey, what did you say? We can go look in our history logs and say, yes, this has been done. We track the open write capabilities so that the volume owner knows which clients are writing to which files. The clients have to tell the volume owner that it has completed the writes so that the volume owner knows that that file is in good shape. If it doesn't get the end right, it has to go repair the file. So all those things and some more are very, very critical. And the directors are keeping, the primary directors are keeping track of those onto the NVDIMM drive. That's so it doesn't lose them if they have a power cycle. What if the whole director fails? The primary director is sending these critical transactions to the backup. So if the primary disappears, the backup has all these critical transactions. The presidents can just say, all right, backup, you're now in charge. You are now functioning as the primary director. You're now the active director. The director will load its logs and it will resume operations. But there is about a 90-second failover in this in which the volumes go down. We don't want that. So we're just going to move these services over. So we're going to move this service to one of the other directors, and there's only 3 of them. So this is kind of easy. We could move it to 1, 2, but that's kind of a double move because if you move it to the backup, then it's got to get a new backup. So I would suggest that we move this one to 1, 3. How are we going to do that? It's easy in the GUI. By the way, you don't move a volume service if this is in distress. If the service ID is says it's degraded, there's no backup or anything like that. Sometimes you have to move it, but you want to talk to us first. If there's no backup and any little blip happens while we're moving it, we could lose those transaction logs. And if that happens, then all the volumes of the volume service have to undergo mandatory FSRC file system recovery. There's really not that much to recover, but that process is going to walk all the objects in the file system, make sure the attributes are all right. It's going to walk all the directories, make sure the directories points to real objects in the reverse, and that all the directories are reasonable, readable. That takes somewhere between 2 minutes and 2 days. Depending on how much, how many objects are in the volume and a number of things. So we don't want to lose the logs. But this is all green, so we can go ahead and move this. We're going to go down here and we're going to select this one, and it happens to be the first one. There it is. And we're going to move it, we said, to 1, 3. So we're going to scroll down here. We're going to move it to director 1, 3. And we've got 2 buttons, move service and move backup. We are moving the primary service. So we're going to go move. It takes just a second. Okay. And for some reason, this doesn't update right away. But it did say that it moved. On our console, the PanCli command vol service list. Rid of this black. That's because it. On typewriter. This updates immediately. You can see that 08 is now indeed on 03. Now it's updated here as well. Okay, so we can see that there's another primary. This one was the one for the root volume. There's another primary here that we don't want to go down when we remove this director. There's this one. Which director do you think we should move this volume service to? What do you think, Mike?
I would do it to the same one we just used.
I couldn't hear you, I'm sorry.
I would do it to the same one we just used.
Well, I wouldn't, because the backup is 1, 3. And plus, if we did that, 1, 3 would have 1, 2, 3 primaries. You want these kind of balanced. In fact, they can only have 5 total, primary and backup. But even if that were not the case, we want this to be balanced because we don't want 1, 3 to have more than its share of the metadata load. Metadata load when clients are asking for callbacks, for caps, should reconstruction start. The primary volume owner is the one that schedules reconstruction, that figures out what volumes need to be, what objects need to be reconstructed, and is kind of charged. So I would suggest that we move this one to 1, 2, because 1, 2 it only has 1 volume service and it's not the current backup. Not a huge big deal if you moved it the other way, but that's what we would recommend. Does that make sense?
Yes.
Okay, so let's do that. Going to choose, let's see, 9. And you can, this is a little helpful because you can see that it says that the primary is 1, 1. This time we're going to choose 1, 2. That's what we want. So we're going to click Move Service. Now, it takes just a little while to do it because the president has to actually copy all those shut down the volume services on the primary, copy all those transaction logs from the one director to the other, bring it up on the director, and then it says, yes, I've successfully moved the service. So let's look at our pan claim. One of these windows, was it? Let's do this again. Service list. And yes, 1, 1 is not the primary for any of them. We want to check our balance a little bit. So 1, 2 has 2 primary. Now these are a little bit more, have a little bit more load than these 2. We've kind of overloaded 1, 2 a little bit because it has data in Scratch and home and projects and software, probably not nearly as robust, but this is only for a minute. So, and now the GUI has caught up as well. The default sort in PanClide is by director. The default sort here is by the service ID, but look, we can sort by primary director. We can sort by backup director. We can sort by just about any of these. And look, here's our historical event log. So let's just look at the historical event log because we talked about that earlier. And here it is. It's filtered for that volume service that I just clicked on. It says, look, I mean, this is before, during the upgrade. And it says, volume service moved. It was moved from this director to this director, and it gives the hardware serial numbers, which is not all that helpful, but it's been like that for some time. Okay, so we're going to go back to storage, back to service ownership. Okay, so note also that these volume services have to be online. If the Pan Manager service that runs all these is not healthy on these nodes, the volume service may be offline. And if that's the case, the volumes will be down. But this would show why they were down. And if that was the case, the president would in fact fail the volume service over to another director. The Pan manager has to keep heartbeat with the president so the president knows if it's healthy and it needs to be failed over or whatnot. Okay, so in this case, we could indeed replace 1, 1. Now, actually, I wish we had done 1, 2. There's another thing we have to do because, well, plus 1, The other thing we have to do is go to hardware. Really. And realm management. If we were to place 1, look, it is in the rep set. We do not want to just fail something out. Let's actually assume that we were going to replace 1, 2. I want to just show you how we're going to remove it from the rep set. What do you think we're going to do?
Well, I would imagine that click the remove button.
That's right. This is not the president and it's not the M console. So it shouldn't be a big deal. Look, there it is. Nothing bad happened. If it were the M console, the GUI would disappear for about a minute, but it would come back. It's not a big deal. It's not in the data path, doesn't interrupt the jobs. But because it would interrupt the GUI and because I'm connected through the APIPA thing, I would have to go move my cable to the other director. I'm sorry? What did you say? Let's go back. I'm sorry. Let's go back to service ownership. And we've discovered that actually it was 1, 2 that we wanted to move. So let's move these things back so we can remove 1, 2. Let's move this 09. Which director do you think we should move it to? This one right here. Which one is not the backup?
I'm having a hard time understanding the screen.
I can't hear you, Mike.
I'm sorry. I'm having a hard time understanding the screen because it says backup director node, and each one of them is a backup director node.
But the backup director node for this volume service.
Oh, I see.
This just apply, the backup relationship is per volume service. So 1.3 is the backup for this volume service. 1.1 is the backup for this volume service. Does that make sense?
Yeah, so then we would want to move that to 1.1.
Yes. So we're already dialed up here for 1, so we're going to move it to 1, and we're going to go move service. So again, just a little bit, it's moving the logs, moving the logs. There it is. Okay. So now, and the GUI hasn't updated quite yet, but PanFS has. So now let's move the other one. This would be 17. Which director is the backup service for just this volume service? It's 1.1, right? So we're gonna now this one's updated. So we're gonna move this one to which director?
1.3.
That's right. So now we're gonna move dot 17. At 17, right there, you can see that it's on 1.1. And we're gonna move that to 1.3. Again, it's not a huge big deal if we moved it to 1.1, but the president would have to do a double move. It would have to overwrite these logs and then enable a backup again. So we're going to keep it simple for it. We're going to move service. Check PanFS. Oh, look. This volume's, this is actually offline. And now it's back on the line. That it was just offline for a second while it was being started up. Well, it hasn't updated yet. We didn't see that last time. And GUI still hasn't updated. You see that you're online, GUI, come on. Here's the volumes. They're all good. Let's go back to volumes, service ownership. Now the GUI understands that they're online. So now, are we good to replace one? As a matter of fact, we will wait until we get to the replacement article to talk about that. But we've done the preparation that the article is going to talk, that our topic is going to talk about. Let's go check on that drain. So let's go to hardware, drain status, and drain is a very slow process, and it's going to say that it's taking 23 hours. Let's check on the status and reports, the storage statistics, and 24 hours is actually very good. Drain is supposed to be slow. It is throttled, and it's moving just some components at a time. It's not particularly fast. We see now that 1.2 is, it's not a hugely below, but let's now say that hardware problem is more severe. And suddenly this OSD just stopped responding entirely. So that can get rid of. I lost my network connection to my client because I can either connect on the network to the clients, or I can let the realm connect to downloads, but not both. Yeah. Okay, so I'm in. So that's not the window I want. This is the one I want. I just queried this OSD. I'm gonna power it off. I could have used the GUI that I showed you, but this is very, very convenient. Okay, now on my client, this is a console to the client. The realm has not noticed that this is down yet. And the realm constantly polls the directors, but for the storage, unless a client or a director complains to the president, it really doesn't poll the okay. Console's finally responding to me. Okay, so now I'm going to Uh-oh. Ow, looky there. It's noticed. And we are in warning state here. That one. Let's click on the enclosure view just to kind of see how this looks. And we see that we have a warning for ASD 1.2. We had that in hardware too. Well, we had a bunch of things, but when we go back to look and see what's wrong, we see this is yellow. Let's go see what's wrong with this enclosure. We say that the node is unavailable. Not responding, drain suspended. You cannot drain something that is offline. So we could even go into the node. We can see that it is not responding. Let's see what's happened to our volumes. Got warnings that one OSD is not responding. Some of these are degraded and some of them are online. Does anybody know why some are online and some are degraded? Let me give you a hint. I'm sorry?
Because it's a set 2.
Yes, very good. This OSD is in set 1. The set 2 volumes are not affected. Okay, so we don't want little blips. We do not want to start reconstruction if an OSD panics and reboots. So we're going to wait 6 minutes, and those volumes are going to be degraded for 6 minutes. And the president is sitting there polling that OSD, is pinging it, and it can't even return a ping. If it could return a ping, it would do some more advanced tests. It would ask it what its boot state is. It would ask it a little bit about its internal file system. But it can't be pinged, so it is in not responding space. It has started the timer, and it's going to wait 6 minutes. So, console.
There is somebody in a lobby. Can you please let him in?
Yes, I will. Thank you. And thank you for that. I just started LS on this to kind of look what happens. It's still just degraded. That's all it is. And our task in progress, it says we're 1 OSD down. Let's go look at our blade set.
So one question.
Yes.
If the one OSD is now down, why it's showing a degraded?
Well, that's exactly what we want. Degraded means that there's 1 OSD down. That means that not all the OSDs. What would you expect except for degraded?
No, since we are using a RAID 6, it should not show anything like this.
No. It's still degraded.
Okay.
It's degraded. Everything is accessible, but it is degraded. It is missing something. That is the definition of degraded. So
Yes.
our blade set is, we're going to go into the set 1 details. And we see, again, an alert. 1 of 12 OSDs is online. We've got 2 available spares and 2 requested. So we're still waiting for 6 minutes. Now, what's going to happen is after 6 minutes, the president is going to put some of the volumes into reconstruction state. They will still be degraded, but each volume owner director is going to start reconstruction on one of these volumes. Each director can only schedule reconstruction on one volume at a time because it's going to go through all the object space in that volume. It's going to tell the OSDs, tell me which components you have and give me the attribute that points to the next OSD in the ring or in the map of those that object. I'm going to see if that OSD is missing any components. If it's not, it's all good. I'm going to skip it. If it's missing one component, I'm going to reconstruct it. I'm going to create I'm going to tell another service, the recon worker, I want you to create a component on this other OSD that wasn't part of the ring. That's why we have more OSDs than we have. We don't stripe across all our OSDs. And then that recon worker, for every stripe in the RAID in that file, it's going to read all the stripes, the parity. It's going to figure out what was missing, and it's going to recreate or reconstruct that component on the new OSD. And it's going to be for each component that has to be reconstructed, it's choosing different OSDs. So the 6 minutes has not yet passed. Get the pen command up. Ah, look, PanCli is now saying that reconstruction is going on. Let's see if the GUI is caught up. This is why we like to troubleshoot with PanCli. It's just faster. All right, look, it says about a minute ago, volume reconstruction began. And now what we say is, and I just degrade, all these things are degraded, but let me lower the resolution just a little bit so we can see the whole thing here. Data is reconstructing. Home is reconstructing. Oh, why are only 2 of these reconstructing is because we only have volume services on 2 of the directors. So now what we're going to let's now say that we have replaced 1, 2, because I want to straighten that out. So 1, 2, we have a brand new 1, 2. These things are now unbalanced because 1, 3 and 1, 1 are the only ones serving volumes. So we want to move some of these back to 1, 2 so that we can have reconstruction on all these things. And it would probably, the realm is a warning state because there's reconstruction and there's OSD. I also want to show you the hardware. Okay. Look, instead of, there's still a warning for this whole node, but instead of a yellow dot, it is now a gray dot. That means it is now reconstruction. It is offline. The realm is not using this data, but is still a member of the blade set. We do not want to replace it until reconstruction has completed. If we find that we fix its problem, we can actually gracefully take it out of reconstruction. So we want to just leave it alone. It is in reconstruction status. Let's look at the blade set. Look at the detail for set 1. Look what's happened. As soon as Reconstruction started, we're writing to reserve space. We have consumed one of the spares. That means that it used to be 2 available and 1 is down. That's because, well, 1 is in Reconstruction. It is still a member of the blade set, but we're not using its data. So that's why there's a longer story to that, but we're not going to tell it. And now the status is 11 of 12 OSDs online. Okay. So now let's say we have replaced Director 1, 2, and we want to move the services back. Let's actually see which ones are in Reconstruction. I wanted to go to volumes. Okay. Let's look at volume recovery priority. By default, the root volume always reconstructs first, and it's finished. See, our services, by default, Reconstruction works on, if we have a RAID 5 volume, it should reconstruct first, and it's not for some reason. Oh, that's because I put the recon priority down on data. Let's say that we actually want Scratch to reconstruct faster than data. We can change the recon priority here. You can see what's going to happen. I think the recon priority is fine up here. We're reconstructing on home. Actually, I think that we want to leave Scratch the way it is because it's a larger volume, and I want this actually to complete today so we can see what happens. So we got Reconstruction going on dot 17 and dot 9. So we're going to go back to service ownership. And we need to move some back to 1, 2. So 18 Reconstruction is not running on it. That would be a good one to move to 1, 2. Oh, well, it's the backup. I'm going to move it on that, do that anyway, because if we move a volume where Reconstruction is running, Reconstruction starts over. So we're going to move 18 to 1, 2. It doesn't really matter which one we do. We can just show that it does, in fact, work. The main thing is we need to get some stuff on 1, 2. Okay, we're going to go move service. Successfully move the service. And the GUI is a little bit slow. And it's on 1, 2. Look, it moved it to 1, 2, but there's no backup. Why is that? Assigning the backup would restart Reconstruction. So during Reconstruction, if there's no backup for some reason, the president will not put one there. Let's look at our, all right, so we're caught up. Let's look at our balance. 1, 3 has data in Scratch and root. Each volume service should have 1 full, and one of them should also have the little root volume. 1, 2 has 1 full, 1, 3, 1, 1 has 1 full. I think we're good right here. And the GUI has not noticed. The GUI has not noticed that we have no backup on this. The volumes, when you're seriously troubleshooting volume services, you always want to use PanFS. So now let's go look and see what's going on with our volumes. We do have the warnings, though, have told us that a volume service doesn't have a backup. Now there are 3 volumes in Reconstruction. Why is that? Because we have 3 directors and they can each schedule Reconstruction. Okay. Now let's go to the volume recovery priorities. And by default, this is organized by director. Okay, so this is all good because projects is the only volume in this data service that need reconstruction. Software is on another data set, so we don't need to do anything there. And we don't even have an ETA on home. Home has a whole lot of tiny, tiny little files. Reconstruction is going to take longer. Data has larger files. Reconstruction is going to go much faster. There is an overhead for reconstruction. So volumes with tons and tons of little files take longer. Volumes that have fewer numbers of large files take a smaller time. Okay. So note that Scratch is one down, reconstruction required. The clients are able to access Scratch. And if they do and access an object, the volume owner is going to go reconstruct it for them, even though it's mostly reconstructing data. This is called reconstruction on demand. We want to hold that down because reconstruction on demand reconstructs one object at a time, where the batch reconstruction is 50 objects at a time. But all these volumes that are degraded are perfectly accessible to the clients. It's just that reconstruction is running on some and not on the others. Okay. Now we're going to leave that there. Let's go look at our status and reports one more time. Storage statistics. You can see that 1.2 is now completely dashed out because it is a member of this blade set, but it's not being used. So we don't care about its disk utility, its total used and available, just completely irrelevant because reconstruction it does not participate in its reconstruction at all. It's just sitting there dead weight. The directors and all the other OSDs are the ones that are active in the reconstruction of this node storage node. And reconstruction space is going down as it's being filled up with the capacity used that used to be on this OSD. Okay. Questions on this so far? All right. I'm going to stop the recording.